All right. So next up, when we're talking about money, we're going to look at compound interest annually, which means per year. And just to kind of recap from last class, because I want to tie it into what we're doing this class, is that from example 1, find the amount in a bank account if $1,000 is invested at a rate of 8% for 3 years using simple interest. So this is from last class. All right. So because it's simple interest, I'll be looking at my simple interest formula, which is I is equal to P times R times T. All right. And so when I go through the question now, it says find the final amount in a bank account if $1,000 is invested. So we're investing, and that means our principal is $1,000. It says at a rate of 8%. So R is, again, equal to 8%. And as I mentioned last class, percent's useless to us in calculations. Got to convert it to a decimal. So I divide by 100% and I get 0.08. T, we got T, 3 years, which is great because our time has to be in years when you're dealing with simple interest. And we want the final amount, it says. All right. Now to find the final amount, we're going to have to find the interest first. All right. So now I'm ready to substitute into my formula here. And so I've got I is equal to, I got my principal there, which is $1,000. My rate, 0.08. And my time, 3 years. And, well, this one is easy because I can just multiply my 3 numbers to get my amount of interest. And it ends up being, let's see here, let's grab a calculator, $240. Now, that's not what it's asking. It says the final amount in the bank account. Now, again, the final amount in the bank account is that you have your principal, the money you put in there, plus interest that you made on that money, if you're investing, of course. So our principal here was $1,000, and plus we made $240 in interest. So a grand total, what's going to be in the bank account is, add those numbers up, we get $1,240. All right, so that was simple interest. Now, here's the key. Here's the difference, is that note, simple interest does not count the interest earned by the interest after year 1 and 2. So it doesn't include that interest. Now that's going to be the difference here when we start now talking about compound interest. Because compound interest means after each year, the money that is in the account has interest added to the principal money. And then what happens is your interest makes interest. So if you're investing, that is a great thing because your money you made is also making you more money. You're getting paid for interest on interest. But if you're borrowing, terrible thing, because it's like because again, I've talked about how an interest is like a tax for borrowing. Well, when you have compound interest, it's like a tax on the tax. So not only are you getting taxed on the money that you borrowed, but you're getting taxed on the money that was taxed to you because you borrowed. Not good, obviously. Now, we've got a formula for our compound interest, and it looks like this, where we have A, you're going to see a lot of the same variables we've been dealing with. A is equal to P times 1 plus R to the power of N. Now, like I said, most of these variables are what we've seen before. So where A is the accumulated amount or final amount. So we'll go with accumulated amount. P is the principal still. So that's either the amount of money that you're borrowing or that you're lending. R is the interest rate. That's the same. One's a little different that we never had before, and that's N. And that is the number of years. All right, so there's our formula. A is equal to P times 1 plus R to the power of N. All right, so we're going to practice using that formula. You'll notice there's no big capital I here. In fact, this is a 1 here. So let's make that a 1. All right, so here we go, using our formula. So I'm going to write down my formula because I know I'm going to end up using it here. So we got A. Again, that's our accumulated amount is equal to P times 1 plus R to the power of N. All right, so example 2. Find the final amount in a bank account if $1,000 is invested at a rate of 8% for 3 years using compound interest. So this is exactly the same question that we just did, the first example. Right? We have $1,000, 8%, 3 years, but simple interest in the first one. All right, now look at this. So we on to this one here. All right, same values, except we're going to write them down a little bit because first off, it says find the final amount. Well, I'm looking for my A. All right, again, we're investing $1,000. So that's my P, still the principal. My rate, still 8%, and I still need to convert that to a decimal, so 0.08. And then N is the number of years. So N is our 3. All right, so now I'm going to substitute into my equation here first off. So I have A is equal to P. We have 1,000. All right, 1 plus, we have our 0.08. That's our rate, and our N is 3. All right, so I've substituted in. Now I'm going to look to do is use BEDMAS to solve for A. And so the first thing is I got to do brackets. I actually have some brackets this time out. Well, not only do I have brackets, but there's something going on in there. And so I got my $1,000. And then, well, 1 plus 0.08 is 1.08 to the power of 3. All right. Well, next up to follow BEDMAS is onto the exponents. Just did brackets. So we have A is equal to 1,000. Now times I take 1.08 and tie it to the power of 3. To the power of 3, I get 2 decimal places, 0.26. All right. And now I multiply the two of those, and in the account, I would have $1,260. Now, in simple interest, it's a very small difference, but there is a difference because simple interest, if you recall, our final amount was $1,240. But because this is compound interest and interest is charged on interest, you make a little bit more money because we're investing this time. Of course, you're going to pay more money if you are borrowing. All right, so let's try a couple more of those. Find the final amount of interest earned if $5,000 is invested at a rate of 15% compounded annually for 6 years. All right, so again, I know I'm going to end up using my formula here, so I'm going to write her down. We have my A is equal to P times 1 plus R to the power of N. All right. Let's see here. So find the final amount of interest. Okay, so that is saying I equals, we need the amount of interest, which is our capital I. Now, still $5,000 is invested. So that's my principal once again. My rate, it says 15% compounded annually. Compounded, that's why we're using this formula. But again, I got to convert that to a decimal and divide by 100%. And then my N, number of years, well, this time it is 6 years. And so what I'm going to be able to find here is the accumulated amount. All right, and that's going to help me find the interest. So it's a couple steps here. All right, but same old, I am going to substitute in my equation here. So I have A equal my principal. This time we got $5,000. I got 1 plus my rate of 0.15. And this money is invested for 6 years. Okay, so once again, I've got to follow Bedmas here. All right, so I got to do the brackets first. So I got my 5,000. Nothing crazy in the brackets here because I have 1 plus 0.15. Well, that's going to be 1.15. And again, to the power of 6. All right, so now it's time. I got to do the exponent next. So I've got A is equal to 5,000. Let's see here. Take that 1.15 to the power of 6 and end up with 2.31. All right, now just to multiply next up. Ooh, we're going to get a much bigger number. And let's see here. I get 5,000. Oops. All right, let's see here. So I take my 2.31, I times it by 5,000, and I get 11,550. But that is not what the question's asking me. It wants to know the final amount of interest. And again, your accumulated amount is the result of taking your principal plus the interest that you've made, again, when you're investing. So if I take my $11,550 for my accumulated amount, I invested $5,000. Well, the remainder of that is interest. So I am going to solve this equation by just moving that $5,000 over to the other side of the equation, which of course means if it changes sides, it changes sign. All right, so it's going to be a minus 5,000, and the amount of interest that is earned, I subtract those two, and I end up with $6,550. Well, this person actually made more in interest than they actually invested. Not bad. Again, high interest rate and a long time in the bank. Not a bad deal, though, if you put $5,000 in and you pull out $11,000 and $550. All right, let's try one more of those guys. Let's see here. Jennifer's investment has grown by an average of 12.6% per year, compounded annually. So again, that's telling me got to use my compound interest formula over the past 7 years. Okay, how much would her investment of $2,000 made, I should say 7 there, folks, 7 years ago be worth today? Okay. So again, we got compound interest. So there's our formula here. A is equal to P times 1 plus R to the power of N. All right. Now, Jennifer's investment, so I'm just reading the question again, has grown by an average of 12.6% per year. All right. So my rate is 12.6%. Won't say it again, but I'm going to flip that to a decimal, of course. There we go. 7 years. So that's telling me that's my N value there. And she invested, I guess, $2,000. So that's our principal. And we're going to find out how much her investment will grow today. So that's how much it's accumulated to. All right. Got my values. Just time to substitute in. All right, so we got A is equal to, how much we invest? $2,000. Keeping it positive today, no borrowing. Then I got 1 plus my interest rate, which is 0.126. And that's going to be to the power of N. All right, well, next up, I'm going to, follow Bedmas to solve. So we got A is equal to 2,000. Brackets here, well, I take that 1 and add that. Well, I'm just going to have 1.126. And I forgot the fact that n here is 7. We're doing 7 years here. So put that there, which allows me to do my exponent. So here we go. A is equal to 2,000. Let me see here. I got 1.126 to the power of 7. To 2 decimal places, I get 2.29. All right. And then I'm going to multiply those two. Let's see here. So 2,000 times 2.29, we end up with a grand total of $4,580. Another example of investing $2,000 and you actually walk away with more money, double the money that you invested. But again, that's compound interest. Again, really good if you're investing, really poor, not a good thing if you are borrowing. But again, it's the difference between compound interest and simple interest is that in compound interest, the interest is being added to the interest, in this case, every year. All right, now